This is lesson for 1-5, converting in scientific notation. Scientific notation is an efficient way to express really, really large numbers, like numbers in the thousands or millions or billions, and really, really small numbers, microscopic numbers, numbers that start with 0 point. So there's two different forms. You have scientific notation, which you have a number times 10 to an exponent to a power, and then standard form, which is just as a regular number. What you're going to be doing today is converting back and forth between scientific notation and standard form. Scientific notation, this first number in front of the times 10 has to be in between 1 and 9.9 repeating. It can't be less than 1. It can't be 0 point anything. It can't be a negative number. And it also can't be bigger than 9.9 repeating. So it can't be like 12 or 130 or anything like that. That first number has to be in between 1 and 9.9 repeating. You always have a times 10. It's never a times 2 or a times 5. It's always a times 10. It's never a plus or a minus either. It's always times 10. Then you have your exponent. Now, with your exponent, if it is a positive exponent, that represents a really, really large number, a number that's in the hundreds or thousands or hundred thousands or millions or billions. A negative exponent is going to be a really, really small number. It always starts with 0 point. Anytime that you have a negative exponent, that number always starts with 0 point. So it's always a decimal. Some examples of when scientific notation is better to use. The distance from the sun to Pluto is almost 6 billion kilometers. 6 billion is really long. That long number to write, 6 with 9 zeros after it. 6 times 10 to the 9th is shorter and easier to write. Going the opposite way with a negative exponent, the mass of a molecule of caffeine is 0.00032 kilograms. Instead of writing all those zeros, 3.2 times 10 to the negative 25th is a lot easier to write and read. So to convert a number into scientific notation, you are going to start at the left and put a decimal point after the first non-zero number. Write that number in front of the times 10. And then to find the exponent, you're going to count the number of places you move your decimal to the right or to the left to get to the end of the number or the original decimal point. So let's try a couple of these. If we have the number 30,000, we're going to put a decimal point after our first non-zero number. Write that number down in front of the times 10. Now in the number 30,000, the original decimal point was here at the end. So we want to count how many places we need to move the decimal point to get to the end. 1, 2, 3, 4. Since we moved our decimal point 4 places, our exponent is a 4. If we have the number 2 million, we're going to put a decimal point after our first non-zero number, so after the 2. Write that number in front of the times 10. And now we got to count to the end. 1, 2, 3, 4, 5, 6 places to get to the end. So our exponent is a 6. When you have a number that starts with 0 point, I know right away that I'm going to have a negative exponent. So I can write my times 10, and I'm going to put my negative sign in front of my exponent right away. Because anytime it starts with 0 point, it is going to be a negative exponent. You're going to do the question the same way. You're going to put a decimal point after your first non-zero number. So after the 8, write that number down in front of the times 10. Now, we're at the end here. We want to get back to our original decimal point. So we're counting 1, 2, 3, 4, 5 places. So it's times 10 to the negative 5th. Put a decimal point after the first non-zero number, so after the 2. Write that number down in front of the times 10. And then 1, 2, 3 places to get back to your original decimal point. So that is times 10 to the negative 3rd. So let's practice with a couple more of them. 5,000. Put a decimal point after your first non-zero number. So after the 5, write that number down in front of your times 10. 1, 2, 3 places to get to the end. So it's times 10 to the 3rd power. 80 million. Put a decimal point after your first non-zero number. Write that number down in front of the times 10. 1, 2, 3, 4, 5, 6, 7 places to get to the end. So our exponent is a 7. 0.000007. Put a decimal point after your first non-zero number. Write that number down in front of the times 10. 1, 2, 3, 4, 5, 6 places to get back to our original decimal point. But our exponent is not a 6. Our exponent has to be a -6 because our original decimal started off with 0. 0.04. Put a decimal point after the 4. Write that number down in front of the times 10. 1, 2 places, but it's not a 2. It's a -2 because we started off with 0. Going the opposite way. So now we're taking a number that's in scientific notation and making it into a normal number. Now, there are rules that you could follow. You could put a decimal point after the first non-zero number, move the decimal point the same number of decimal places as what the exponent says. If it's a positive exponent, you're going to make the number bigger, so you want to move your decimal point to the right. If it's a negative exponent, you're going to move the decimal point to the left to make it a smaller number. And then you're going to add zeros into placeholders as needed. However, you could, and this is the way that I'd strongly recommend it, you could just type these right into the calculator. You always have a calculator to use, so you could type it right into the calculator. Let me show you both ways. So 3 times 10 to the 4th. We could put a decimal point after our first non-zero number, and then whatever our exponent is, that's how many places you're moving the decimal point. It's a positive number, so we want to make the number bigger. 1, 2, 3, 4. So this is where our new decimal point is. Fill in our placeholders with zeros. So we have the number 30,000. Now the calculator way is a lot easier and a lot quicker. All that you had to do for the calculator way was just type this right directly into the calculator, exactly how it says. 3 times 10, caret button 4, and hit equals. When you do that, you get that same answer. You get 30,000. The calculator does the work for you. So 7 times 10 to the 3rd. Again, just type it right into the calculator. You get 7,000. With negative exponents, we're going to put a decimal point after the first non-zero number, so after the 9. And then this time we have a -3. A negative exponent, we want to make a small decimal answer. So we want to go to the left. 1, 2, 3. There's our new decimal point. Fill in your placeholders with zeros. So we really have the number 0.009. Now you could put a 0 in front of the decimal point as well. Now you could type this one right into the calculator as well. You're just going to type in exactly what it says. So 9 times 10, caret button, -3. Make sure you use that negative button, not the minus sign. And again, you get 0.009. The calculator does the work for you. 3 times 10 to the -2nd is 0.03. Looking at some more, again, I would just type them right into the calculator. 7 times 10, caret button 3. When you do that, you get the number 7,000. 4 times 10 to the 5th. You get the number 400,000. 3 times 10 to the -5th, you get the number 0.00003. And 5 times 10 to the -4th, you get the number 0.0005. So again, all that you want to do with those is just type it right into the calculator. Put 4 more up on the screen. You could try these on your own. Pause the video, try these on your own. So these two, all that you're going to do is type them right into the calculator. 3 times 10 to the 5th is the number 300,000, a 3 with 5 zeros. 9 times 10 to the -5th, 0.00009. Now these other ones, we need to make them into scientific notation. So you put a decimal point after your first non-zero number, write that number down in front of the times 10, and then we're going to count 1, 2, 3, 4, 5, 6, 7 places to get to the end. So it's times 10 to the 7th. Put a decimal point after our first non-zero number, write that number down in front of the times 10, count back to our original decimal point, 1, 2, 3, 4. So it is a -4. It's a -4 because our original decimal started off with 0 point. So again, use your calculator. Your calculator is your friend.